Example 3 says, if the equation 2x squared plus 5x minus the quantity 3x plus 4 equals 0 has two real and distinct roots, find the range of values of the constant k. So we start off, we have this equation, 2x squared plus 5x minus the quantity 3k plus 4. And that equals 0. So it says that it has two real and distinct roots. Okay, so that piece of information is very helpful. So two real and distinct roots for a quadratic equation. What do we know is true based off of that statement? That's what we need to use. We need to take this piece of information and say, okay, if I know that this is true, then what else can I say? What else can I use that is true? Everything that you do in math, it needs to come from a truth. It needs to come from a law or an axiom or something that says, if you see this, this is what you're allowed to do. You can say this as well. So what this means is that our discriminant, which is b squared minus 4ac, it means that it has to be larger than 0. Remember, if we have two real and distinct roots, that means our discriminant is positive. If we have two real but of the same roots, the exact same number, like in example 2, we have a discriminant that has to equal 0. And if our discriminant is less than 0, which that means that we're going to have non-real roots. We're going to have some imaginary answers. Complex answers with imaginary components. But that is what happens there. So we know this to be true. So this is our blueprint for success. Use that piece of information to move forward with the problem. Well, in order to figure out all the rest of the stuff, we need to know what A, B, and C are. Well, A is the number, again, that is attached to our squared term. So A is going to equal 2. Our B is the term that is attached to x. Okay, just the one that's attached to x. So we only have one x term, and it has B is going to be 5. It's a positive 5. Now our C here is this remainder here. Now we want to make sure that we calculate this the right way. C is negative 3k plus 4. If you want, you can simplify it, but you can leave it like this too. You could say that it's the same thing as negative 3k minus 4. That could be useful to you, but so long as you follow the order of operations and you are detailed in your notes, there shouldn't be an issue regardless of which one you decide. So now we go forward and we say, okay, well, what's b squared? B squared will be 5 squared. And we subtract away 4 times A, which is 2, and times C, which I'm going to go ahead and use that, which I'm going to use this one. I think that because I see this negative here, I can cancel it out. You don't have to, but that one works just fine. And so this is going to be negative 3k plus 4. And we know that that is greater than 0. So a good hint as to when it's greater than, when it's less than, it says range. Well, a range isn't a particular number. It is a set, a continuous set of numbers. That's going to be greater thans, less thans, in between type explanations, and so on. So now we want to go ahead and continue to simplify. So 5 squared is 25. This makes negative 8. And we're multiplying that by this negative 3k plus 4. Well, these negatives are going to cancel to make a positive. So I'm going to get it away here. So 25 plus 8 times 3k plus 4 is greater than 0. And so I'm going to have 25 plus 24k plus 32. And sometimes you can skip through a few steps if you need to, but it's always important, especially when there's a lot of clutter, just to make sure that you're not dropping anything, you're not going to lose anything, so you can keep the right answer. Now from here we've got 25, and we can combine that with our 32. That's going to make 57. And then we have plus 24k. We have that. So now what we can go ahead and do, and when we know that that's greater than 0, so we need to solve for k. What I would do is I would move my 57 over to the other side. Oops. That's going to make 24k is greater than negative 57. Right? So when we subtract it over, we're just kind of replacing the sign. And then we're going to divide by 24 on both sides. So the 24 divided by 24 takes care of itself, right? And that becomes a 1, and we're going to have k has to be greater than negative 57 over 24. And you may say, that's a really weird number. That's okay. Different examples are going to give us different options. And depending on what we're looking for, we may have some weird numbers. Don't be shocked if you get weird numbers in this course. Just make sure that once you get them and you're applying your math correctly, you can always look back and check your work as you go. It's helpful to work with a partner so you don't make a little tiny mistake. But just be clean and careful and make sure you're writing your stuff down. Make sure that if you find something that you really like to do, stick with it and just learn. And don't fear mistakes. Just work with the process. Work through the answer to the end. If you make a mistake in the middle, those are things that we can correct over time. And those sometimes they just happen even to myself. So just keep working, but mainly think about the process. What is it that you can do with the information provided? And in this case, we could use the discriminant, the properties of it, to help figure out an answer to this question.